Yeah. Hi, everyone. Can you hear me well? Okay. So thank you for coming to this session. Title is Full Stack Web in F#. My name is Tomasz Heimowski. I come from Poland, and I have a rare opportunity to work full-time with F# and full stack, let's say, with F#. And I also contribute to open source, mainly around the areas that we'll be exploring today. I have a website at theimowski.com, and I use the Heimowski nickname on Twitter and GitHub. Full stack web. So let's make a little survey first. Raise your hands if you are a web developer. Okay, and please keep your hands up if you consider yourself to be a full stack web developer. All right, and if you are a full stack web developer, raise your hands if you need to use more than one language for your job. Right, so quite a lot, right? So today we'll see how to be a full stack web developer using just a single language, which is F#. And we'll be basing our sample application on this thing called To-Do MVC, which you might have heard of. How many of you have heard of To-Do MVC? Not many. So To-Do MVC is basically like a showcase for different applications, for different technologies, showing the same application written in front end. For example, with Angular, React, with different transpiled to JavaScript compilers, just to showcase how to implement functionality, certain functionality in a given language. So this is for the front-end stuff, but there's also a project for the backend stuff. So To-Do Backend shows how to implement the backend for To-Do MVC application from the backend perspective. And today we'll see how to do both at the same time. And we'll do that in F#. So how many of you know F#? Not a lot. So I'll try to briefly explain what F# is. It comes from Microsoft. It was born as a Microsoft research project, but it's really open source by heart. So it was even open source before Microsoft released to GitHub all the .NET Core and ASP.NET Core stuff. So even before that, F# was open source. And I'd like to emphasize that it's a general purpose language because many people think it's only for specific areas or domains, but it's not. We can write standard business applications using F#, which I'll show you today. It's functional first, which means that it encourages you to use functional paradigm, but it's fully interop with .NET, so you can still use object orientation and other things if you want to. It works on .NET Mono, .NET Core, as we'll see today. Also, it works in your web browser. And we'll be exploring something called SafeStack. So we have this thing called SafeStack, which basically consists of 4 different projects. And if you don't know F#, you probably just recognize Azure from this list. But don't worry, we'll go step by step through each of the remaining 3 and explain them in details in practice during live coding sessions. So keep fingers crossed. And SafeStack, in a big picture, combines, as I said, several open source projects. It's F# end-to-end, which means you write F# both on backend and on backend and client side. And the acronym SAFE fits nicely into its powerful type system in F#, so we can say that it's type safe. Cloud ready, which means that the template gives us a couple of options to deploy to our favorite cloud provider really fast and easy. And to start developing SafeStack applications, you need to have .NET SDK 2.2 installed, which I believe comes with the newest Visual Studio. So that's good. Additionally, you need a global .NET tool called Fake in version 5. And for the front-end stuff, you'll need to have Node.js installed and a package manager. Yarn or NPM will do that. But if you're more into Docker side of things, you can install the nightly build version of Visual Studio Code, which is called Insiders, and they have an extension called Remote Containers, which allows you to develop fully in an isolated container, which is pretty cool as well. And to create a safe project, you need to use the .NET new command from the SDK, from the CLI, to install the template, safe template, and then create a project from that template. And then you need to use the Fake tool to build and run the application, and afterwards it will open up in your browser. So that's what we're seeing here on my second screen. So on the left-hand side, you can see this is my Visual Studio Code editor opened with a terminal at the bottom where I have the Fake build script running. And on the right-hand side, it's my Chrome browser where the application is being displayed. It's not very rich, as you can see right now, but we'll change that. So let's decode safe stack letter by letter. And the first letter stands for Saturn, which is basically a library, a thin library on top of ASP.NET Core and Kestrel, written in F# and meant to be used by F#. And let's basically see in practice how it looks like to develop applications using Saturn and F#. So first thing what I do is go in my browser to an HTTP client extension to show you how invoking HTTP calls looks like. And on the left-hand side in my editor, I have server.fs file open with F# sources. I'll not go through every details because we don't have enough time for that. So there are some boring modules over here for configuration and Azure helper functions because we'll be using Azure next. But the most interesting part starts here. So we have a thing called web app, which is basically like a set of rules for handling the requests. So first rule is for get HTTP request to the API/init URL, we want to use that handler. And this handler is a Lambda function which takes two parameters. It takes next, which is of type HTTP func, and context, which is basically ASP.NET Core context. And HTTP func is a function from HTTP context to a task of HTTP context option, which allows in a nice way to compose those in a functional way, those handlers. And within the body of the Lambda function, we have a task computation expression. So this is an F# thing. And you can think of that as in C# you have async await Lambda expressions. So that's pretty same like here. And this operator return bank basically stands for a return await like in C#. So you can think of that in this way. And basically within the body, we're creating a value of a type called counter with the field set to 42, and then returning a JSON representation of that object. So if I click send, as you can see, I get back a value of 42 for the localhost API init. And so let's first see how we can implement loading the to-do list from the server side by the Saturn API. And to do that, let me first create a new type called to-do. And the type will consist of ID field of type integer, description of type string, and is completed, that will be a flag, so a Boolean. And this is a F# precore type, and it's immutable by default. And if I want to create an instance of that type, to make it a constructor, I need to pass all fields at once. Otherwise, it will not compile. So all the fields need to be set, right? And so ID will be set to 0. The description will be implement server side using Saturn. And then for the is completed flag, we'll set that to initially to false. So this instance is immutable, so that's the default behavior in F#. And if you want to make something immutable, you need to use the immutable keyword explicitly. And I'll do that right now for a temporary in-memory database, which will consist of a sample to do a single element. So by the way, this is how you create a list in F# by using square brackets. And now we have our in-memory fake database in place. Let me create a function called load, which will again use a task computation expression, but will just return the database as it is. And having that in place now, what I can do is change the URL API to-dos. And here, instead of the counter, I'll load those to-dos from the load method. So again, load, let's bank the keyword over here means await, like await in C#, right? And here, instead of the JSON representation of the counter, I'll return the to-dos. So now if I go and click save, as you can see in the terminal, the application is running in a watch mode, so it's being recompiled automatically for me and restarted. So now if I go to get API to-dos URL and click send, I get a JSON representation of a list of to-do objects. Cool. So now we have the load function in place. Let's proceed with save function. So we want to do the backwards way, so save to-dos from client to server. And to do that with the fake in-memory database, let's create a function called save, and it will take to-dos as a parameter. And again, within a task, it will basically assign the to-dos to the database. And we can use that operator over here because we declared the database value as mutable. And now let me copy this guy over here and create something similar. But here instead we'll be using post method. So for post HTTP requests to API to-dos URL, what I want to do is instead of loading them from the in-memory database, I want to bind to my ASP.NET context. So I can use bind model async function, passing in to-do list as a generic parameter. So this basically means read the to-do list from the HTTP request body and serialize it to to-do list. And then I want to call the save to-dos. And again, do bank means like await action. Okay, so, and I want to return not a JSON representation of the to-dos, but instead a simple string saved. Let's go. Okay, so it's being recompiled right now. Let's wait until it finishes. And I have in my next step prepared a list of to-dos for today's session. So those 4 to-dos correspond to 4 letters of the save acronym stack. And first one is already implemented, so I marked it as true. Let's send it to the server. We get back the saved response, so hopefully it succeeded. If I get API to-dos, I get now the list of 4 to-dos. Right. So here we use Saturn and use F# to implement the web server, and that's the backend side. Now, A stands for Azure in SafeStack, but I bet you already know pretty much about Azure, so I will not try to invent something new here, but instead let me just show you how easy it is to set up safe applications with Azure. And here, instead of using the in-memory database, what I'll do is to grab a snippet that I've prepared before. Let me just remove this in-memory fake database. We'll not need that anymore. Click Save to recompile. OK, so I've basically replaced the load and save functions with Azure corresponding functions. So basically, I'm using Azure blob container with a file inside. I'm writing a raw JSON to that file and then reading that and deserializing. Nothing fancy here. I just had to implement the functions for serialization and deserializing JSON. And other than that, basically using Azure storage. So now it's recompiled, and if I click Get API to-dos, I get a list of 5 to-dos because that's what I had in my Azure storage. But if I go back to Post API to-dos and say that I want 4 to-dos, 2 of which are marked as completed, then hopefully it's being saved to Azure. So now if I click Get APIs to-dos, I get the list of 4 to-dos from the Azure storage. So that's pretty much it about Azure. Nothing fancy here. As I said, more interesting stuff to come. And by the way, the template gives a really easy option to set up for Azure App Service. So after invoking the template with a special parameter, you can use a different command just to place it straight to your Azure account. Azure App Service, and we have also a couple of other deployment options baked into the template, so I encourage you to check them out. But you might be wondering how the hell is it possible to write F# for the client side, and that's where Fable comes in, and Fable is basically an F# to JavaScript compiler. So we write code in F# and it compiles to JavaScript. So let me show that in practice. And first, I'll go to the application itself, and it's very ugly. So what I'll do is to grab the CSS declaration that's prepared by the To-Do MVC project so that the application looks a bit better right now with the layout, fancy layout. And now let's go to client.fs file, which is a separate file. And all the F# code that you can see in this file is being compiled to JavaScript. And let me for now skip most of the code and go to the very end, which is basically where we are running the application. And as you can see here, we have a function called run, which takes a to-do list as a parameter, and it basically runs the application. And here I explicitly invoke it with an empty list. So what I want to do is now to add a code to the front-end side to load the to-dos from the backend and display them in the application. And to do that, let me call this function load and run. And I'll use against the computation expression, but this time it's a promise computation expression, so not task, because on JavaScript we deal with promises for async stuff, and that's the mechanism in F# is extensible, so we can use it here as well. And I'll bind the to-dos for the result of fetch, which is the API for running HTTP from JavaScript. And fetch as to-do list from /API/to-dos URL, and then run with the to-dos. So having that in place, as you can see, load and run is a function from unit to a promise. And by the way, unit is like void in C#, but it's not really void. It's an object that can have just one constructor. But you can think of like void. Okay, so let me now invoke the function load and run and pass it to promise.start, click save, and as you can see, the client side is running in a watch mode as well. So after I click saved, it recompiled and refreshed automatically for me. And by the way, this operator over here that you can see is called pipeline in F#. Basically, it takes stuff that's on the left-hand side and applies it to what you have on the right-hand side. So you don't need all the parentheses, which is pretty nice. OK, so you can see I displayed the list of to-dos in my application. By the way, can you see that? Actually, I'm seeing that pretty good in my PC, but as you can we somehow twist the display? Because can you see, for example, the first one? Not really. That's a shame. What can I do? Color. Can I do some, I don't know, high contrast stuff? Does it change anything? No. It's those CSS guys. Shit. Okay. Anyway. Basically, those two to-dos at the top are marked as done, so they are crossed out. As you can see, the other two are not completed yet. Yeah, OK. So what I can do within the application is basically to list those to-dos, and there I have an input at the top where I can write something, and I can press enter, which adds that to-do to the very end of the list. But it's only on client side, so if I refresh my browser, it's gone because it was not persisted in Azure storage. So we need to fix that and implement the save method for the client side now. So to do that, let me go over here, and I'll implement save, passing in to-dos as to-do list, and again use promise computation expression. And here I'll invoke also fetch API, but this time post. And as you remember, I'm returning a string, so I need to pass that as a type parameter over here to /API to-dos and the to-dos that we got in the parameter. And all I need to do is to invoke that save with model to-dos and do promise.start. So if I recompile that, hopefully now if I add a new to-do over here, click enter, it's added to the list, and if I click refresh, it's still there. You can barely see that. Right, okay. So that's the Fable part. Basically, Fable allows you to compile F# to JavaScript, and we saw how to write the load and save method for the front end, and to load to-dos from the server, and then save back the to-dos to the backend from Fable, from F#, from JavaScript. Yes, but you might be wondering how is it possible to run like whole application on the client side, and for this we have the last letter in safe acronym E, which stands for Elmish, which is basically like a user interface library or framework, if you like, which follows model view update MVU pattern. And if you're not familiar with MVU pattern, I'll try to briefly explain that because it's pretty simple. And the first building block in MVU, M stands for model, so model is the first thing. And basically it corresponds to whole state of the application on the client side that we currently have. So we have here a list of to-dos. We have the field of called input, which is basically what we have in the input that I'm typing in currently. And we need to keep track of the next ID for the to-do to add. So basically we need somewhere to track it to generate that so that we have unique IDs. And to calculate the next ID based on the list of to-dos, if the list is empty, then it's 0, and otherwise we take max of those to-dos, the maximum ID, and add 1. And the init function here creates an initial model in our application. So to-dos will be fetched from the server, input will be initially an empty string, and next ID is generated from the function that I've just explained. Next building block of MVU pattern is called message. So message corresponds to every possible action that I can do on my client-side application. And as you remember, what I can do right now is to type something into this input over here. And every keystroke I push on my keyboard, this message is being triggered with a value of the input. So I will need to handle that somehow, and I'll show you in a second how. And second thing I can do is to press enter, which will add that to the list. And this is the add message. So basically, I have just two things I can do within my app right now, and we'll add something soon. And to handle those messages, that's where the update function comes in. So update function takes next message, current model, and computes next model. So basically like a step in a stateful model, if you like. And here we're using a technique called pattern matching in F#, where we look at the value of the message, and if that's an update field message, basically we copy whole model and just change the input to the value that we got from the message. And by the way, this syntax over here stands for where's that? The syntax over here stands for copying an object in F#, but just amending one field or some fields. But for add message, we need to compute whole new model because every field is being changed. So next ID will be incremented. The input will be reset to an empty string. And the to-dos need to be calculated based on the add to-do function. So add to-do basically creates a new to-do based on the model input, the value that we've got in the input. The isCompleted flag will be set to false initially, and ID is taken from the next ID within our model. And then we basically return a list concatenated with current to-dos and the new to-do. So that's the update function. So we've got M and U covered, and V for view is still outstanding. Here I have a little helper function to determine whether a key press is an enter key. And this is where the view comes. And here we're using React.js under the hood, which fits really nicely into this whole stack. And this function over here, view input, is responsible for rendering this label over here and the input itself. Then we've got a function called view to-do, which is responsible for rendering just a single to-do on the list. And then view to-dos is a function which renders all the lists, right? So all the to-dos. And finally, we've got a wrapper function called view, which basically wraps all the other functions and calls them with the with the current model. So if you can see, for the view function, I'm passing the current model, and I can basically easily render what's within the model. So all the to-dos, whether they completed or not, etc. And I also got a dispatch function passed to the view, which I'll explain in a little bit. And the rest of the code is what we've already explored, just running the application. Okay, so to show you in practice how this looks like, let me add a new feature. So I want to actually check a to-do that it's completed or uncheck to make it not completed. And to do that, let me go to just before the label with the description. And here I'll add an HTML input. So if I click save, it's being automatically recompiled once again. As you can see here, an HTML input, you may probably not see that, but that's an HTML input that's appearing here, so it's automatically showing for us over here. But we don't want that input to be of type text, so instead I'll do type checkbox, and that should change to a checkbox that you can also barely see, but if I check it, as you can see, it's checked. But it looks really poor, but thankfully, we have got the CSS layouts, so we can use a class from the CSS definition called toggle, which will mark the checkbox, and they will look a bit better. But still, nothing really happens when I click them. So what I can do is to bind to checked property, which takes a boolean. And if I mark all as checked, as you can see, every checkbox has been marked right now, but that's obviously not what I want to do. And instead, what I want to do is to mark that based on the is completed field. So whenever a to-do is completed, only those two at the top that you cannot see are completed. Right, and yet I want to add a handler to onChange event, where I'll do something like that. So I'll want to invoke toggle with to-do ID message and dispatch it. So here what's happening, I'm attaching a handler to onChange event, and here is a Lambda function where I want to dispatch, so this is the function that we got to the view, a toggle message, which I'll need to create in a second, with current to-do ID. So let me go to message type and add this new message, toggle of ID of type int. And now, as you can see, the update message, the F# compiler warns me about not covered cases. So I added a new case, but it's not covered, and F# compiler helps me with discovering that. And let me just paste a snippet here for handling the toggle message. So basically what's happening here is I'm iterating over all to-dos, and if the ID matches, that I'm toggling the is completed flag. So now if I click this guy over here, let me just refresh because something with cache happened. If I click that, as you can see, it's normally if the display was better, you would see that it's struck through, but now it's gone, basically. Yeah. Okay, so that's how MVU basically works. And just to emphasize that, let me add one more small feature. How are we with time? 5 minutes. Okay, so yeah, I think we'll do that, hopefully. What I want to do is to add a button just afterwards. And the button will have a class from CSS called destroy. So you might already figure out what it will do. So it appears over here, this little red square. But if I click it, nothing happens because I need to attach to onClick event handler and dispatch message called destroy. So pretty same what I did before, right? Need to create that message. So new message destroy of ID of type integer. Okay, and again update. It warns me about not covered case. So let me just quickly grab the snippet to implement that. So basically here I'm filtering out the to-do that matches the ID from the message. Right, so now if I click this one, it's gone. And the changes are persisted in the Azure storage because if I refresh, as you can see, the new to-do is gone. Okay, I will not mark those even though we've already done them, but I will not mark because I want you to see anything on the screen. Yeah, so that's E for Elmish. So to sum up, Safe Stack stands for those 4 projects: Saturn, S for Saturn, web server in F#, A for Azure, obviously, F for Fable, F# to JavaScript compiler, and E for Elmish, user interface library or framework for writing apps on the client side using model view update pattern. And what are the practical benefits of using Safe? So number 1 is one language to use on both client side and server side. But you might be wondering that you need to learn F#. But trust me, after you cross this initial barrier, it's very easy to use. And I did that already, and I never want to come back now because I have C# background as well. The templates, Safe template comes with plenty different options, so you can choose different layouts, deployment options, which is pretty nice. And as you saw, the development experience is taken to the next level. So you don't need to come back to your Visual Studio or terminal and click build, recompile, rerun the application every time you make any changes. It's running both on the client and server side in watch mode. So anytime you click save, basically it recompiles automatically for you, and you can see the changes immediately. So like immediate feedback loop, which is pretty nice. And Fable integrates very nicely into the existing JavaScript ecosystem. So we don't try to reinvent the wheel here, and we can use all the existing tools from JavaScript ecosystem, which is pretty huge. Microsoft is also involved into Safe Stack by regression testing new version of .NET Core with Safe Stack. So they make sure new version of .NET Core that Safe Stack still works with newer version of .NET Core. And there's a community behind Safe Stack and a couple companies that provide commercial support. So use Safe to use Safe Stack. Yeah. And what's more about Safe? Sharing code. So let me just show you one thing. Because server and client are written in the same language, you can share code between them, which is pretty obvious, right? So in client, I have a type to do, and on server, I have basically the same type. So what I can do is to grab this guy, delete it from server, and copy that to shared module. And now I'll need to remove it from client as well. Let just the server restart. Now save the client. Okay, so as you can see now, we have shared code between client and server. I can do the same with the URL, for example, API to-dos. I will not have enough time for doing that right now, but you can imagine some validation logic can be duplicated between server and client in the shared module. Remote DevTools debugger. Hopefully I can show you that because it's very nicely integrated, I can use cool tools like Redux extension in Chrome. So take a look at that. I'm doing something, adding that, marking as check, no, destroy. Okay, and I can replay the history from the beginning, and it's showing what's happening in the application. So I can use it to debug my application and trace errors. And I can even export that to a file and send to my colleague to reproduce a bug, which is pretty huge, right? And yeah, that's available for free. We have something called full stack debugging in Visual Studio Code. So you can set breakpoints in both server side and client side and step through those. React.js comes with this thing called server-side rendering. So basically on Node.js on the server side, you can prepare your layouts. And we can do the same in SafeStack. So instead of using Node.js, we're using .NET Core, which is much faster than Node.js in this manner. And we still have the benefits of server-side rendering. And SafeStack is getting its momentum because it recently appeared on ThoughtWorks technology radar, as well as we get a number of podcasts and even appearances, all under these links if you want to explore them. And last slide, resources, documentation, some videos, GitHub organization, and link to the slides, which I think I'll post on my Twitter as well, and source code that we just implemented today. And by that, I'd like to say thank you, and I think now is the time for questions if we have.
Have you tried Blazor, and does it work with F#?
Okay, so Blazor doesn't work with F#, as far as I know. I haven't tried it. I have just heard about it, and like the major point about Blazor is that it's using WebAssembly. which is still like in very early stages, so we must agree on that. Plus, it's like generally said that WebAssembly is not meant to replace JavaScript fully. So I think WebAssembly has like its own use cases, which might not be for standard like business line of business applications. Plus, it's C#, where I prefer F#. So, yeah, but Blazor obviously like is a corresponding project for C# developers. Yeah.
Any more questions?
Hello, thank you for your talk. And do you aware about some production experience with Save Stack? Maybe
Okay,
some
so,
projects?
In my commercial project, we're not using Save as per se because we're not using the web server part, but we're using Fable and Elmish for the production application. And we're also sharing the code, F# code, with a console application we have for .NET Core and old .NET version as well. So I could say that we're using a Save Stack to an extent, not using the web part. So that's my use case, and I know of a couple of companies in Germany, in San Francisco, and in UK that are still using Save Stack like that you saw today in their production applications.
Okay, thanks for the presentation. My question, you said a lot about pros, and you didn't say it about disadvantages.
About what?
Disadvantages of this stack in
Yes.
comparison with classic style.
No disadvantages.
Okay, maybe performance, maybe, I don't know, something doesn't implement it, like in comparison with classic style. What do you know about it?
So for the front-end stuff, like because Fable is still relatively new, there might not be every JavaScript library might not be yet ready to use for Fable, but there are already a couple of which there are bindings for them, so we can use those. But if you experience that you need to import and interop with some other JavaScript libraries, there are a couple of options. So you can use, there's a project that takes TypeScript definitions and tries to do like a Fable bindings for those. It works most of the time, but sometimes TypeScript has some fancy features that do not map one-to-one to F#. So it's in some cases it might not work when, and then you need to create your own bindings, for example. So that might be a disadvantage, but I think like if it comes from the front-end side of the different technologies, basically the interop is always like a challenge in some cases, right? Yeah.
Do we have more questions? Okay, then the last one for me. You said that Fable compiles F# to JavaScript. What option do you have when you deploy the application and you need to debug it in production? You still have to know JavaScript and you debug JavaScript in deployed system?
You mean like to trace in production, right? The issues. So you can, there are source maps, which basically source maps stand for like mapping the sources from F# to JavaScript. So you are able to set breakpoints within the browser, and that maps to an F# code. So that's one possibility, and also you can try to reproduce the bug like locally with that as well, or using breakpoints within Visual Studio Code.
Thank you. That's it. Let's applause and thank you to Tomasz.
Thank you.